Hello, good evening students. Today we have solved few problems on design of illumination. These problems are very simple but are basic to design problems. So before going to that, we have to understand some terms or definitions which are mainly used in design of your buildings. So first of all, MHCP, mean horizontal candle power. It is defined as the mean of candle powers in all directions in horizontal plane containing the source of light. Second one, MSCP, mean spherical candle power. It is defined as mean of candle powers in all directions and in all planes from the source of light. Third one, MHSCP, mean hemispherical candle power. It is defined as mean of candle powers in all directions above or below the horizontal plane passing through the source of light. Then lamp efficiency. In general term, efficiency is the term, it is the ratio of output divided by input. Now lamp efficiency, it is defined as the ratio of luminous flux to the power input, because it emits the flux. Flux is expressed or measured in lumens, output, power output. Power input is, we are giving wattage. Hence the lamp efficiency is expressed as lumens per watt. Remember, lumens is output, input we are giving electric power, watt, lumens per watt is known as lamp efficiency. Number 2, space height ratio. So it is defined as the ratio of horizontal distance between adjacent lamps to the height of mounting. That means it is the horizontal distance between adjacent lamps, neighboring lamps, to the vertical space of lamps above the working plane. This is called space. Space between, distance between two lights, height, then vertical height. The name itself gives space height ratio. Okay. Third one is utilization factor. It is a well known fact that total lumens given by the lamp, it is not reaching to the working plane. Getting the idea? What is the light output is there? Light emits the light output. It doesn't reaches to the working plane. It may be due to dust. It may be due to absorption of light by ceiling or wall or reflectors. Hence, utilization means how much lumens are utilized at the working plane, then how much lumens are given by the lamp. It is the ratio. Getting the idea? If 100 lumens are emitting by the lamp, this 100 lumens are not utilizing to the working plane. That is, actual lumens available at the working plane, then total lumens given by the lamp. Okay. It is defined as the ratio of total lumens reaching the working plane to the total lumens given by the lamp. This is called utilization factor. If utilization factor is 50%, that means total flux emitted by the lamp is 100, but it reaching to the working plane is 50%. Another important factor, maintenance factor. It is also ratio of illumination under normal working condition to the illumination when everything is clean. It is also same thing. Illumination is everything is clean. That means the lamp is installed at the new condition. Actual working condition means day by day efficiency goes on decreasing due to accumulation of dust and dirt condition or present of smoke condition. All things will affect on the illumination. So, this is called maintenance factor. Maintenance factor is defined as illumination under normal condition to the illumination under when everything is clean. Getting the idea? When everything is clean, it is 100%. Then illumination under normal working condition, it may reduce to 80%. So, maintenance factor is usually less than 1, because 100% it is not possible. It may be 90%, it may be 80%, just like that. So, depreciation factor is also one may be considered. It is just opposite to maintenance factor or just opposite to this ratio. Illumination when everything is clean to the illumination under normal working condition. Hence, we are going to get the depreciation factor is always greater than 1, because it is inverse of maintenance factor. These all factors are useful while designing the lighting schemes in building. So, we have to start from very simple problem. The flux emitted by a lamp in all directions is 1000 lumens. Calculate its MSCP. So, MSCP equal to F divided by 4 pi. Formula is there, we have to remember. So, total luminous flux emitted equal to 1000 lumens, it is given. Hence, MSCP equal to F divided by 4 pi. F is total lumens, that is total lamp output. Flux radiated, it is in lumens. 1000 lumens is given, 4 divided by pi. MSCP of lamp, it is 80. Starting with simple problem. Number 2, a 250 volts lamp has a total flux of 3000 lumens and it takes a current of 0.8 ampere. Calculate lumens per watt, MSCP per watt. So, what is the input? That is wattage is input, voltage is given, current is given, V into I gives watts, 200 watts. Output of lamp, it is lumens. Output of lamps is also given 3000 lumens. Hence, lamp efficiency or lumens per watt. Lumens per watt equal to output of lamp in lumens divided by wattage of lamp. So, 3000 by 200, we are going to get 15. So, MSCP equal to F divided by 4 pi. Standard expression is there, lumens is given. So, we are going to get this value as 240. Then question asked is MSCP per watt. MSCP of lamp divided by wattage of lamp. We are going to get 1.2. Third problem, a 0.4 m diameter diffusing sphere of opal glass 20% absorption encloses an incandescent lamp with a luminous flux of 4850 lumens. Calculate the average lumens of sphere. So, what is the total flux emitted? That is 4850. This incandescent lamp is fixed with diffusing opal glass. It has 20% absorption. Hence, 80% of lumens is available. Hence, we have to calculate outcome or output of this incandescent lamp with this diffusing sphere. That is, output lumens becomes 80% of this. 0.8 times of 4850. So, it becomes 3880 lumens. Surface area of globe, that is 4 pi r square, 16 pi. Then average lumens of sphere. Average lumens of sphere, flux emitted per surface area. Flux emitted per surface area, it becomes 7720 lumens per meter square. A lamp of 500 watts having MSCP of 1000 is suspended 2.7 meters above the working plane. Calculate illumination directly below the lamp at working plane, lamp efficiency, illumination at 2.5 meters away from the horizontal plane from vertical below the lamp. So first you try to understand the problem. What are the conditions are given? You try to sketch. So a lamp is given of 500 watts having MSCP of 1000. It is fixed from vertical height of the plane, that is 2.7 meters. At point A to the lamp, vertical height, it is 2.7 meter. Point A. So second condition he asked, calculate the illumination at point 2.5 meters away from the horizontal plane from vertical below the lamp. That means horizontal distance from point A is 2.5 meter. That is at point B, calculate the illumination. This is the problem. Try to understand. Vertical height, it is 2.7 meters. Luminous intensity, it is 1000. Luminous intensity, that is 1000. So number 1, illumination directly below the lamp at working plane at point A, that should be equal to I by h square. I by h square. That MSCP value or luminous intensity is 1000. Height, it is 2.7 meter square. So 137.1 lux. Lamp efficiency equal to luminous flux divided by power input. So luminous flux equal to 4 pi into MSCP. MSCP equal to lumens divided by 4 pi. By using that equation, total lumens equal to 4 pi into MSCP and total wattage is 500. So we are going to get 25.13 lumens per watt. Number 3, illumination at point B. For this you can use the expression I, that is MSCP value, divided by h square into cos cube theta. Theta is the angle between. From the diagram you can observe. So h is 2.7, cos theta you can calculate. After that you convert into cos cube. Hence this value we are going to get 54.2 lux. A lamp having uniform candle power of 200 in all directions is provided with a reflector which directs 60% of the total light uniformly onto a circular area of 10 meter diameter. The lamp is hung at 6 meter above the area. Calculate the illumination at center. Number 2, at the edge of the surface with and without reflector. With and without reflector. L is fixed. L is fixed. This diameter is given. Diameter is given 10. So it becomes radius 5 meter, 5 meter. So at the central point, vertically below the central point, 5 meter one side, 5 meter one side. At the central point, it is of A. It is of A. Its height is at 6 meter, vertical height h equal to 6 meter. Then we are using the reflectors. We are using the reflectors to focus the light on surface or required object. Reflectors are using for different lighting schemes, direct lighting, indirect lighting, semi direct or semi indirect. So then these reflectors also reduces the intensity of light. Okay, how much? If it is given 60%, then from this output goes 60% of total light given. That's the problem. Number 1, illumination at the center area without reflector, that is Cp divided by S square. Candle power is given 200, vertical height is h, 5.56 lux. Illumination at the edge of surface without reflector, that is again we have to use Cp by S square into cos cube theta. So cos theta you calculate, vertical height h is 6, this point lamp to B, it is under square root of 5 square plus 6 square, then you are getting the cos theta value, then that value is 0.786 cos cube, cos theta equal to 0.768, that is cos theta, then cube of this value. So we are going to get as 2.52 lux. With the reflector, the illumination at the edge and at the center will be same, since the reflector directs the light uniformly on the surface. Total lumens given out, that is 4 pi into candle power. So we are going to get 800 pi. Total lumens reaching the surface with help of reflector. Reflector it is 60%. 60% of this above flux reaches. You multiply by 0.6 into 800 pi. Total surface area, that is pi r square. We are going to get 25 pi meter square. Then average illumination with reflector, calculate total lumens reaching the surface divided by total surface area. So we are going to get as 19.2 lux with the help of reflector. Another problem, an illumination on the working plane of 75 lux is required in a room 72 meter into 15 meter in size. The lamps are required to hang 4 meter above the working bench. Assuming a suitable height ratio, utilization factor 0.5, lamp efficiency 14 lumens per watt, and candle power depreciation of 20%. Estimate the number of lamps, rating of lamps, and arrangement of lamps. This problem is more important. Such type of problems are useful for design and arrangement of lamps to get the better illumination. Sir, area to be illuminated, calculate the size of the room, area to be illuminated, that we are going to get 1080 meter square. Then proposed illumination or illumination required 75 lux. Total lumens required, that should be equal to A into E, illumination into area. So total lumens it is around 81,000. What is the utilization factor? 0.5. Maintenance factor it is not given. Depreciation factor is given 0.2. Hence 1 minus this depreciation factor becomes maintenance factor. So total lumens required or gross lumens required, that should be equal to A into E divided by utilization factor into maintenance factor. So it becomes 20 to 500. Total wattage required of the system, that should be equal to total lumens divided by lamp efficiency. Lamp efficiency in lumens per watt. Total lumens is in lumens. Lumens will going to cancel, remaining is watt. So we are going to get 14,464 watts we have to plan. Hence we have to go use of 80 lamps, 80 lamps, total 80 lamps. Then we have to select 4 rows, 4 rows, each row consists of 20 lamps and giving a spacing of 3.6 meter in length, 3.6 meter in lengthwise, 3.75 meter in widthwise, and spatio height ratio, space height ratio of 0.9 and 0.93 respectively. So finally we are going to use 80 lamps. Then what is the rating of each lamp? So that you have to make the calculation. Wattage of each lamp equal to total wattage divided by number of lamps. So it comes around 180.8 watts. Then which are the ratings available? Actual ratings available lamp is near to this value is 200 watts. Hence we have to select 200 wattage lamps. Final selection. Now you can see the plan for arrangement of 80 lamps. Lengthwise 72 meter, widthwise 15 meter. First you draw the plan of your given room size. After that 4 rows, 4 rows. In each row 20 lamps are arranged with a spacing of 3.6 meter in spacing between adjacent lamps. All, but at the edge, last lamp and first lamp at the beginning and edge of that, it is half, 1.8 meter, 1.8 meter. Getting the idea? In similar fashion, widthwise 1.5 meter is there. Spacing between the lamps is 3.75 meters. At the edge only half of this one, 1.875 meters. So lighting arrangement should be done in such a manner all working plane should get uniformly illuminated, uniformly distributed of illumination. Getting the idea? It may be factory lighting, it may be building lighting, or it may be monument lighting. Illumination should be uniform. Hence, when you are getting the uniform illumination, your arrangement of lamps also uniform. Okay, you work out this problem. Another 1 or 2 problems we have to look after tomorrow, or design of street lighting. Thank you to one and all.